So now today's topic is potential energy in an external field. Now we are going to consider potential energy of a system of two charges in an external field. That is, external field is already there and we are interested in finding out the potential energy because of the two charges. But the external field is not created by Q1 and Q2. It is already there. Okay. Now this is our reference. It's a three-dimensional space. You are considering a point here P1. This is Q1 at P1 and this is P2. Charge at P2 is Q2. And the distance between from the origin to this one is R1. This is R2. And the distance between Q1 and Q2 is R12. Okay. Now first of all, this Q1 charge from infinity, it is brought down at this point. Okay. So a work is being done. But a work is being done due to you have some external field. Okay, it is being placed there. So next we are bringing another Q from infinity to this point. But in this case what happens? This second charge is going to experience a work is being done due to the external field as well as due to the field produced by Q1 also. Okay, so two cases has to be considered for Q2, because first for Q1 there is no problem at all because it deals with only with the external field which is already there, whereas for Q2 it will be experiencing the force and it has to do work from infinity to here to this point in an external field, plus it will see a force because of the charge Q1. So it has to undergo two types of fields. Okay, so that's what is being shown graphically. So this is origin. You are bringing the charge from infinity to this point and you are bringing another charge from infinity to this point. So first we will see what happens to Q1. So for work done, charge into potential, Q1 into potential. As I already told you, at infinity the potential is 0. Therefore, the potential difference between that point P and infinity is V. Okay. Now for Q1 work done because by the charge Q1 is Q1 into V, and V is a function of R1. So it depends on R1. So this is first case. Then second, the Q1 has reached that point and then you are bringing the second charge from infinity to the another point, say P2. So in that case work done is Q2 and multiplied by potential at the point P2 and depends on distance R2. That's why we write V of R2. But the second charge has to undergo an field produced by the charge Q1. So for that work done is Q1 Q2 divided by 4 pi epsilon naught R12. So it has to go repulsive or attractive. Suppose if it is positive, both are positive, it is repulsive. So a work is being done because of the repulsive force given by charge Q1. So that also should be taken into account. So work done is Q1, the charge of at P1 multiplied by Q2 divided by 4 pi epsilon naught into R12, where R12 is the distance between the two charges. Now we want the total work done. So potential energy of the system as a whole. System as a whole means we are now considering 2 points. So our total work done is first work done because work done by Q1, work done by Q2, and because of Q1 this Q2 will experience some repulsive force and additional work has to be done. So for that we make use of third case, which is Q1 Q2 divided by 4 pi epsilon naught R12. So if you add all these things, you will get the total work done by the system because of these two charges. and we call it as potential energy of the whole system. Whole system in the sense we are considering only two charges. So that's all about potential energy in an external field. So I have told you all the important points what should be considered. The potential at infinity is considered to be 0. So that is the key point. So since it is a 0 at P1 and P2, if you measure the potential, it will be give the potential difference with respect to the potential at infinity. Thank you for your attention. Thank you. Nandri.